Hello, and welcome to this third tutorial on MIPSView. Here we are going to show you how to define which curves are visible in the viewer and their appearance. We will also show you how to generate plot files and how to switch on and off annotations. In MIPS, curves are stored in discrete disk files, usually in subfolders of the project processing folder. The files have an extension .mip1. The curve selections and their appearance in the MIPS viewer are defined in layout files, which are independent of the data and can be reused to show curves in different projects or at different stages of the processing. Curves which are present in both the data file and defined in the current layout file will be displayed in the viewer. To edit a layout file, click right-hand mouse Layout Editor in the viewer. This presents the Panel Selection tab. The user can then select whether to display one or two auxiliary curve tracks, how many vertical grid lines to show, and which track to edit on the other tabs of the Layout Editor. This tab also allows the user to load and save layout files to the project. To edit the array curve track, click on the tab Multi-Arm Settings. This tab has several controls to set the appearance of the array curve track. Each channel in the array curve set has a fixed center line. When the curve value is the same as the display center ID, the curve is displayed in this position. Normally the display center ID should be set to the nominal ID of the tubular. If the channel value changes plus or minus the swing value, it will display in the center of the neighboring channel. Hence, to make the curves more active and show smaller changes of value, the swing should be decreased. See what happens if we decrease the swing value and click Apply. The data reduction settings control what happens when the display is zoomed out. The software automatically calculates how many samples contribute to each pixel on the screen, based on the depth range, sample interval and screen resolution. In our example, 19 data samples contribute to 1 pixel. If data reduction is set to maximum, the largest of the 19 samples will be displayed. The data readout panel will show reduction max 19. Maximum is the recommended setting for caliper data, as it will show any potential pits and recessed collars at any zoom level. In this example, the perforations of the liner do not appear in the display if the data reduction is set to average, as each perforation is only 1 depth sample wide. However, they are all shown when the data reduction is set to maximum. The color map used for VDL type displays is shown at the bottom of the Multi-Arm Settings tab. It can be edited by clicking Edit Map and launching the Color Map Editor. Several color maps are supplied with the MIPS software, and these can be accessed via the File Load button. The data endpoint controls set the array curve values which map to the first and last colors of the color map. The user can also construct customized color maps. Instructions for this are given in the MIPS user manual. The Panel Display tab allows the user to select auxiliary or non-array curves for display in one of the two right-hand tracks. It also allows the user to set the value of synthetic curves to show as fixed values or use as the basis for shading. Here I'm defining curves for the second auxiliary track. To add a new curve, choose Log for the type of log and select a curve from the pull-down list. Here I'm selecting the eccentricity curve. The curve scale low and high values can be copied from the curve in the row above by clicking on the V. The curves will appear in the viewer when the Apply button is clicked. Curves can be removed from the layout definition by clicking on the cross. To set individual curve properties, select Edit Log and the third tab will update. The curve name and units are read from the header of the MIPS data file. The label name displayed in the curve track header is usually the curve name, but this can be edited by the user. The scale, low and high values are set by the user to cover the expected range of the data. The on-screen range button will set the low and high values based on the minimum and maximum values in the visible depth range of the current data. In the same way as for array curves, the data reduction settings control what happens to the display when it is zoomed out. The line color can be selected by clicking on Change Color. The line width of the curve can also be adjusted. The Shading Rules tab allows the user to set up a series of rules which result in a color or pattern fill between curves in the MIPS display. If a shading rule involves a synthetic curve, this must first be created in the Panel Display tab. Each rule will switch on shading if the first log A is greater than the second log B, and will use the selected color and pattern. Logs A and B can be selected from a pull-down list of curves and synthetic curves. The color can be selected from the standard color palette selection. The hatching or pattern fill style can be selected from a pull-down list of supplied styles. Rules can be defined and then switched on and off using the rule selection buttons. Clicking Apply will show the defined shading in the viewer. When all edits are complete, the layout file can be saved or a new one created using the Save As button on the Select Panels tab. Other controls are available via the right-hand mouse button to change the appearance of the data in the Array Curves track. Right-hand mouse visual caliper lines will switch on and off the display of the array data as curves. Right-hand mouse visual center lines will switch on and off a display of the center line for each channel. Right-hand mouse visual tool upside will switch on and off the display of the tool upside curve as an overlay on the multi-channel data. Right-hand mouse visual show as radii will switch on and off data readout of the arm values, maximum, minimum, mean and median curves as radii rather than twice radii. Right-hand mouse visual multi-arm title will switch on and off the display of the data set title at the top of the array curve track. And right-hand mouse visual VDL shading will switch on and off the display of the data as a color VDL map. When the VDL map color is switched on, the color map and scale bar are shown in the track header. When the MIPS viewer is displaying more than one data file, these are normally available to the user as a series of tabs. If right-hand mouse synchronize panes is switched on, depth selections in one tab are replicated in the other tabs. The user can use this feature to compare two datasets by clicking in the tabs in turn. As an alternative to presenting data as a series of tabs, MIPS can show two datasets alongside each other as tiles using Window Tile Vertical. When the panes are synchronized, depth changes in one pane are replicated in the other. The MIPS package can generate PDF or TIFF format files ready to send to a printer or plotter. The plot definition form is launched from View Plotting. By default, the data and the layout file are inherited from the dataset in View when the plotting form is launched. The user selects a paper size or plotter width and orientation and a depth scale. The depth scale can be fixed, or the selected depth range is automatically fitted to the page. The user selects an output file name for the PDF or TIFF file, the plot resolution, and the type of output, PDF or TIFF. Note that large plots at high resolution will generate very big plot files. More information is given in the manual or via the help web. MIPS has a system to show text or other ancillary data as a series of annotation layers, which can be switched on and off individually or together. These layers are generated by the processing analyst and can include, for example, weld schematics, joint labeling, and the maximum penetration points in each joint. The main on-off switch for annotations is right-hand mouse, Annotations, Show Selected. The MIPSView user can add new text at any location in the data tracks using right-hand mouse, Annotations, Add Text. Any text annotation can be edited by pointing at the text and selecting right-hand mouse Annotations, Edit Text. The Annotation Layer Editor allows the MIPSView user to delete an annotation or change its appearance. The user can select which annotation layers to display using the Annotation Manager, accessed from View Annotations. This concludes the third tutorial on MIPSView. More information can be found in the manual, which is supplied with the software package.